So is my screen visible to all of you? Is my screen visible to all of you? Am I audible?
Yes.
Okay. Okay, so good evening everyone to the week 4 discussion of this course, Computer Vision, and this course was originally taken by Professor Jayanta Mukhopadhyay, Professor, Department of Computer Science and Engineering, IIT Kharagpur. Myself, Ayan Paul, I am a PMRF Research Scholar from IIT Kharagpur, and I am a TA of this course. My responsibilities are I will solve some of the questions that will be very similar to your assignment, so that whenever you will be doing the assignment it will be easier for you. Okay, so that is my duty, but before that I always prefer to have a summary session of whatever has been discussed in this week, and then we will proceed to the question answers. Okay. Okay, and very happy Independence Day to all of you. Today is 15 August, so yeah, very happy Independence Day to all of you. Okay, so let's start the discussion. Okay, yeah. So in the previous class, what we have studied. Okay, let me 1 second. Yeah. So in the previous class, what we have discussed is we have discussed regarding projective. Yeah, very happy Independence Day. So yeah, in the previous class what we have discussed regarding this projective camera projective camera matrix, or projection matrix. Okay, so projection matrix means we are using one camera and we are projecting a scene point to an image plane. Okay, and get the coordinates by the help of the projection matrix. For example, capital X is your real space coordinate, and whenever we are changing it by our projection camera matrix, our point will become small x in the image plane. Okay, that will be small x comma y, because 3D point will be converted into a 2D point, that is x comma y. 3D point will be x capital X, capital Y, capital Z, but after multiplying with the projection matrix, that will be converted to small x, small y, and in the homogeneous coordinate 1. Okay, so that will be that what we have studied in the previous class. Okay, that is small x equals to p into capital X. Okay, today what we will discuss regarding stereo geometry. So previous class, whatever the camera we are using only a single camera, but today what we will do, we will take two cameras and get the image point of the same scene point. That means for the same real world point we will be using two different camera at different orientation to capture a viewpoint. Why? Because we want a distance and to recreate the 3D scene. Okay, so that is known as stereo geometry. So in definition in computer vision, this stereo geometry that today we will be discussing, it refers to the study of the geometric relationship between the two cameras. So earlier in the previous class we were using only one camera. Only one camera means we can get an image point, but we cannot get the corresponding depth, because whenever x, y, z we are transforming with the projection camera matrix, that is p matrix, it is converted to small x comma small y. That means 3D point is converted to a 2D point in a image plane, but a z coordinate is lost. So for that purpose what we have done, yeah, so for that purpose, okay, someone is joining, yeah. So for that purpose what we are doing is we are using two different cameras. Okay, so that is known as stereo geometry. So again, stereo geometry refers to the study of the geometrical relationship between these two camera that observe the same scene, okay, from different viewpoint. So two camera are there, they are at different viewpoint and they will observe the same scene. Okay, why? Because the goal is to understand how 3D structure of the scene relates to the 2D image. So earlier what we are doing, we are only taking a projection camera matrix, we are converting it from a 3D point to a 3D real point to a 2D image point. Okay, but now what we are trying to do by the help of the two camera is to recreate the 3D structure of the scene so that the depth and the 3D shape can be recovered. Okay, so that is known as stereo geometry. So again I am repeating, in the second class we have just talked about the homogeneous matrix. So what is homogeneous matrix? Simple, like two planes are there, two homogeneous planes are there, we are just transforming one point in one homogeneous plane to the same point in another homogeneous plane, okay, by the help of your homogeneous matrix. In the third class what we have done is we have a real 3D point. Okay, then we are using a camera that has a projection camera matrix or projective camera matrix. We are multiplying the projective camera matrix to the 3D scene to get a 2D image point. So actually a 3D image point is converted to a 2D image point. Okay, so that is actually a limitation of a camera, right? Because we cannot capture the actual z coordinate of the real space. We can only capture x and y coordinate, but not the z coordinate. So to capture the z coordinate, what we are doing, we are taking the help of this stereo geometry. What is stereo geometry? We are using two cameras, okay, that will observe the same scene but from a different viewpoint. Why? Because to recreate the 3D structure of the scene so that we get the 3D depth as well as the 3D shape. Okay, so that is stereo geometry. So any doubt regarding this? The difference between the previous class and this class? Any difference between this? Any doubt for this? No doubt, right? Simple. So earlier we are using only one projection camera matrix P. Now we will be using two camera. Yeah, difference between 2D and 3D camera. 2D and 3D camera, there is nothing 2D and 3D camera. All camera, what is the property of a camera? Like you have seen in the previous class, a camera convert a 3D real point to a 2D point, 2D image point. Okay, so in reality or in our real space, all the points are in 3D. Okay, now with the help of any camera, what we do is we are converting the 3D real scene to a 2D image point. So that is with a single camera. But now what we are doing in this class is we are using two different camera. Why? Because earlier the limitation with one camera is we are getting a 2D image point with a 3D for a 3D real space point, right? But now with the help of stereo camera, what we will do is we will can also achieve the depth, that is the z coordinate of the real space. Okay, as well as we can recreate the shape of the shape or recreate the 3D structure of the scene. Okay, so that is the plus point of this stereo geometry. Okay, so in spite of one camera, now in this class we will be using two cameras. So that is the main difference between the previous class and this class. Okay, now let me proceed further. Yeah, so you can see this is one this is actually an image of, you can say, a trophy or a lamp, whatever it is. Okay, so you can see that the same trophy has been captured by two different cameras. Okay, one is this camera, so this camera we are getting one image, and this camera we are getting another image. Okay, so that is known as stereo geometry. Okay, so by this two images, now we can actually get the depth of whatever the lamp or whatever any image point in this any real space point in this lamp. Okay, in this lamp scene. Okay, so that we can achieve. So this is what stereo geometry is. Okay, so what are the key ideas in stereo geometry? Imagine two cameras, left and right, separated by a fixed distance known as baseline. Okay, second, each camera sees the same scene but from a slightly different perspective. So these are the two key ideas of the stereo geometry, that there will be two camera. One camera is known as left camera, that will be on the left side. One camera is known as right camera, that will be on the right side. Okay, and they will be separated by some distance known as baseline distance. Okay, second, each camera sees the same scene. Okay, same scene but with a slightly different perspective. You can see in this example image that each camera, they are seeing the same lamp. Okay, but they are from a different slightly different perspective. Okay, so that is the idea behind the stereo geometry. Now let's move to our geometrical description of the stereo geometry setup. So this is this capital X is your scene point, or the point in the real space. Okay, that capital X is nothing but has coordinate capital X, capital Y, capital Z. Okay, so this is the point in the real world, or your main scene point. Okay, so this is X. Now we have two cameras, right? One is camera here, that has the camera center capital C, and one is camera here, that has a camera center C dash. Okay, so the camera at the left side, we call it as left camera. Okay, and the camera at the right side, we call it as right camera. In nomenclature, how we write left camera? Generally we write left camera with whatever the notation is, like C. Okay, camera center of the left camera we will be denoting by C. But right camera, what we denote right camera we will be denoting by C dash. So anywhere dash is written, you have to understand that it is indicating that these are for right camera. Okay, anywhere there is no dash written, that you have to understand it is for left camera. Okay, so that is regarding the two camera centers, because two cameras, so there will be two camera center. This center is for left camera, this center is for right camera. Okay, so these are the thing. Now for there is a camera, there is a real scene point, so for each camera there will be an image point, right? That we have studied in the previous class only. So the image point will be formed on the image plane. So this is the image plane of the left camera, and this is the image plane of the right camera. So this is what. So image plane is okay, but image point, the image of this capital X by this camera capital C, or this left camera will be small x. Okay, now this image point of this capital X, or the real coordinate, by this right camera C dash will be small x dash. Okay, so two cameras, so there will be two image point. One is the X by our left camera, one is x dashed by a right camera. Okay, so this is the thing. Now the plane on which all the three are three all the three coordinates are: one, the main scene point; second, the camera left camera center; and third, the right camera center. This plane is known as epipolar plane. You can see by this triangle that plane joining the scene point, the left camera center as well as the right camera center, that is known as your epipolar plane. Okay, now there is a term known as baseline. The line connecting the left camera center with the right camera center, this line, okay, this line, what I am indicating, this line, let me show this line, c dash, is known as your baseline. Okay, so these are the things. Now what we are left with, thing called epipole. Now what is this epipole? The point at which the baseline is intersecting the left image plane, that is known as left epipole. Similarly, the point at which the baseline is intersecting the right image plane, that is known as right epipole. Okay, and now what is the epipolar line? The line connecting the epipole with the image point is known as the epipolar line. The line connecting the left epipole with the left image point is known as the left epipolar line. Similarly, line connecting the right epipole and the right image point, that is the right epipolar line, that is L dash. So that is regarding the epipolar lines, that is L dash, epipoles E dash, camera center C dash, X dash are nothing but your image point. By the X is by the left camera, X dash is by the right camera. Okay, and what we are left with, and yeah, we have discussed all the terminology. Okay, now let's see the definitions of it to be more clear. So epipole, I have already told you epipole. So epipole is nothing, this is the most simple definition, found by intersection of the baseline with the image plane, that I have told you already. That baseline is nothing but line connecting the two camera centers C dash. So the line at which this baseline is intersecting this image plane, okay, that in the left image plane, the line in which the baseline is intersecting, that is known as the left epipole. Similarly, the point at which baseline is intersecting the right image plane, that is known as the right epipole. Now there is another definition of epipole. Okay, so another definition is epipole is one image of the epipole in one image is the projection of the optical center of other camera onto that image plane. Okay, so what does that means is E. Okay, E is the left epipole. So E is the image of the right camera center C dash in the left image plane. Okay, similarly E dash is the right epipole. Right epipole is the image of the left epipole in the right image plane. So that is another definition of epipole. So this is regarding epipole. Now epipolar line, simple. Epipolar line connecting the epipole and the image point in, if it is in the left image plane, that is known as left epipolar line. If it is in the right image plane, that is right epipolar line. Okay, so these are the two epipolar line. So let's read this. L is the line in the left image containing all possible projection of points lying along the 3D ray from C through P that intersect the epipolar plane. Okay, so no need to understand this, just understand this. So L dash is nothing but actually L dash is nothing but it is the L dash is nothing but it is the line connecting the left epipole with the left image point, or the right epipole with the right image plane. Okay, so that is epipole. Another definition of L dash, okay, L dash is nothing but actually it is f into x. So we will be discussing what is f. F is a fundamental matrix, we will be discussing next. So you can just understand the simple definition as of now. Now epipolar plane, so I have already told you, epipolar plane is a plane connecting the 3D point, okay, 3D point, that is the real space point, that is capital X, and the left camera center, that is C, and the right camera center, C dash. And baseline, the line connecting this C dash, that is known as baseline. Okay, so this is the thing regarding epipoles, epipolar lines and epipolar plane. So that is known as epipolar geometry. Okay, so any doubt regarding this? Any doubt regarding this? You can please ask. So is it clear now? What is epipole? What is epipolar? Sir, epipolar planes, please explain. Yeah, epipolar plane. So epipolar plane is nothing but a plane formed by connecting 3 points. What are the 3 points? One is your real image point, that is capital real scene point, that is capital X. Okay, you can see here capital X, that is the point at the top, capital X. So that point and the two camera center, one is the left camera center, that is C, and one is the another is the right camera center, that is C dash. So plane formed by X, C and C dash is the epipolar plane. Okay. Okay. Any other doubt? Clear, right? What is a epipole? What is an epipole? What is an epipolar line? Is it clear to all of you? Okay, nice. Okay, nice. Now let's move on to the mathematical relation for epipolar geometry. Okay. So this is, I have already told you, this is a plane. Pi is a plane containing the real space point, that is capital X. Okay. Epipolar plane, that is a plane formed by capital X, C and C dash. We have this epipolar plane, we have this epipole E and E dash. E is the left epipole, E dash is the right epipole. L is the line connecting the image point and the image point in the left image plane and the left epipole. Similarly, L dash is the right epipolar line, that is the line connecting the right epipole and the right image point. Okay, so this we have already discussed. Okay, now there are some terms here that you need to understand. One is how you will get X and X dash. So X and X dash is very easy. How you can get X? X is the image of capital X by your left camera. So X will be equal to Px. Okay, X is very easy. X will be equal to Px. Okay, what is P? P is the projective camera matrix of this camera or the left camera. Okay, similarly, what will be X dash? X dash is also easy. What is X dash? X dash is the the image point formed by image point of capital X in the right image plane. Okay, by camera C dash. Okay, so it will be very easy. X dash will be equal to P dash. Okay, that is the projective camera projective camera matrix for this camera C dash. So your X dash will be equal to X dash will be equal to P dash into capital X. So two things, very easy. So X, small x, if I tell you small x, that will be equal to Px. Okay, that will be equal to P into X, capital X. Okay, P into capital X. Similarly, X dash is P dash into X. Okay, so these are the two you can say two basic relation that we have already discussed in the previous class also, right? Because P is nothing but projective camera matrix of this left camera. P dash is the projective camera matrix of this right camera. So this is the most basic relationship that we have already discussed in the previous class. Okay, now there is another thing known as H pi. What is H pi? Now you can see there are two image plane, right? There is one image plane, that is the left image plane, and there is another image plane, this, that is the right image plane. So in the second class, what we have discussed this homogeneous projection, right? What is homogeneous projection? Homogeneous projection is projecting one image point to another plane by use of homography matrix. So as there are 2 points, there is x and there is x dash. So there will be some matrix that will project this x point to x dash, right, by a homography matrix. So this is h pi. So again I am telling, we have already studied this also, right? X equals to x dash equals to hx, right? That also we have discussed. X is nothing but your one point in one space, and x dash is, okay, someone is joining, yeah, and x dash, what is x dash? X dash is the same point that is projected in another homogeneous space. So this we also know. So here also you can see there is one x dash and one x. So definitely there will be a matrix H or a homography matrix that will be transforming this x dash to x, or vice versa, whatever you tell. Okay, so here what we are telling, yeah, x will be converted to x dash. Okay, so by a homography matrix h pi. So what is this h pi? H pi is nothing but that is denoted by this k dash r k inverse. Okay, now what is this projective matrix? For the left camera, projective matrix for left camera is this p k. K is the intrinsic camera matrix k, and then I 0. Okay, I is identity matrix and 0. That is how we are expressing our you can say left camera projective matrix. And for right camera projective matrix, how we are expressing it as p dash. Okay, p dash equals to k dash into rt, because if we compare the two cameras, so we are actually rotating this camera as well as we are giving some translation to it. So that is why p will be converted to p dash. Okay, so that is why we have this two matrix. One is p for our left camera, p dash for our right camera. Okay, now our thing is how we can find this h pi. Okay, this h pi will convert the x to x dash. So how we can get this h pi? H pi is nothing, h pi is k dash r k inverse. Okay, so k dash r will be taken from our right camera matrix, and k inverse will be taken from our left camera matrix. So by this we can calculate h pi. So if we have h pi, we can directly convert this x to x dash. Okay, that is the image point from the left camera, left image plane to the right image plane, that we can directly convert. Now another thing about epipolar line. So how we can get the equation of the epipolar line? We have 2 point E dash and x dash. So very easy. If we just do the cross product of it, cross product of E dash and x dash, we can get the L dash. That is how we get the equation of line, right? We have already told what is the equation of line. Equation of line is L. Okay, L is nothing but x1, okay, x1 cross x2, okay, x1 cross x2, okay, this is cross product. So cross product of, let's do it by vector, that will be good. So x1 cross x2 vector is nothing but our L vector, that is the line vector. So same thing, epipolar line is nothing but a line, right? That is formed by the 2 point E and x dash. So simple, if we do the cross product of E and x dash, we will get the equation of the right epipolar line. So L dash will be equal to E dash cross x dash. Now the thing is, we can write this E dash as a skew symmetric matrix, okay, and then we can write E dash x into x dash, same thing, okay. But we have known from this, we have already known from this equation that x dash is equal to h into x, right? So in place of x dash, we can just write h pi x, that is this h or h pi or h, whatever you use, h into x, okay, because x dash is nothing, x dash is, okay, someone is joining, okay. So yeah, so x dash is nothing but h into x. So E dash into h into x is your L dash. Okay, now this E dash h is nothing but that is known as F, or the fundamental matrix. Okay, so this is regarding the whole mathematical relation here. Okay, and this is how we can write the e dash x. Okay, e dash also we can write, or we can write e dash x. Okay, so e dash is written in this form. Okay, the e dash x is nothing but your skew symmetric matrix of e dash, that is written in this form. Okay, that also I will discuss when I will solve the question. So this is regarding. So what you need to remember, you need to remember that there are two camera projective matrix now. Earlier there was one camera, so one projective matrix. Now two cameras, so two projective matrix. One is left projective matrix, that is P, and the one is right projective matrix, that is P dash. Okay, so these are the two things. Now now these are the two things. Now thing is how you can get the x or the image point in the left image plane. That is very easy. Capital X is your real points, and you have a projective camera matrix P. So just P into capital X, that will give your small x. Similarly, how you can get x dash? X dash is nothing but x dash you can find by P into P dash into, because here the camera is camera projective matrix is P dash. So P dash into capital X, you can find the small x dash. That is the image point in the right image plane. So these are the two basic that we have already studied in the previous class also. Now as there are two image plane, one is this left image plane, one is this right image plane. So if we need to transform our image point, left image point to right image point, so actually that will nothing but we have to multiply it by a homogeneous matrix, because we are just do the homogeneous projection of one point from one image plane to another image plane. So that we can do by a kind of homogeneous matrix, that is Hx, and that H will be given by this equation. Okay, K dash R K inverse. This K dash R will be taken from this right camera matrix, and K inverse will be taken from our left camera matrix. Okay, so that is Hx. So H also we got to know. Now how we can get this L dash? L dash is very easy. Yeah, please. Any doubt? Okay. Yeah, L dash is very easy. L dash, how we can find L dash? L dash is nothing but E dash cross X dash. That is how we find the equation of a line. If we have 2 point x1 dash and x1 vector and x2 vector, it is very easy. Just do the cross product of this two vector and we will get the equation of a line. Similarly, we have two image point E dash and X dash. Just do the cross product and we will get the equation of L dash. That is also very easy. Now how we can further express this X dash? X dash can be expressed as Hx. Okay, so if I multiply this H with this E dash, then we will get a new matrix known as F, that is fundamental matrix. So that is regarding the mathematical relation of epipolar plane. Now let's further move into this F matrix, that is known as fundamental matrix. Okay, now another thing, what is another significance of this fundamental matrix? Whenever this fundamental matrix will be multiplied to this any image to the image point in the another image plane, then we can get epipolar line of another image plane. Like to get the epipolar line L dash or the right epipolar line, what we need to do? We need to multiply this fundamental matrix and the corresponding image point in the left image plane. So L dash is nothing but Fx. This is another important thing. Now this two I have already discussed regarding the definition of the epipolar or epipoles. So how we can get the epipolar point or epipoles? That is very easy. E is nothing but your image of this point C in the image of this point C in the left image plane. Okay, so E dash will nothing but E dash is nothing that, let's take E dash. Yeah, E dash is P dash C. That means multiplication or the image of this C with respect to the image of this C with in this image plane. Okay, right image plane, that is E dash. Similarly, what is E? E is image of C dash in this image plane, that is the left image plane. So that is how we express this E and E and E dash, that we can express. So that also we have discussed regarding this. So very easy. E is the image of the right camera center C dash in the left image plane. Similarly, E dash is the image of the left camera center C in the right image plane. So that is regarding the E and E dash. So it is very easy. E is P C dash. Similarly, E dash is P dash C. So that is how we can write it. Now L dash equals to fx. Similarly, what you can do is this you already know that x into L is nothing but that will give you 0. So by that you can get this true equation. So this true equation is now it's not needed, but this you have to remember, and this you have to remember. Similarly, this you have to remember, that is this f will be equal to h into E dash into h. Okay, and h you have to remember, h will be equal to this k dash r, that is from this p dash and k inverse. So that will also you have to remember. So these are the things that you have to remember. Now about essential, so let me ask you first. So is it clear to all of you, the equations? Is it clear to all of you, the equations? Any doubt? Clear, right? Sir, will this mathematical formula be asked in offline exam? Not mathematical formula, but you will be given question. So yeah, in those question you will have to use this mathematical formulas. Okay? Is it clear? Like what happened? What is happening in this slide? Is it clear? Clear, right? Any doubt you can ask. I know this thing can be a bit tricky. So any doubt you can ask. So what are the things you need to remember? You need to remember that x equals to px. Yes, what is k dash r represent? K dash r. K dash r is a yeah, you know P, right? P is a right projective camera matrix. Okay, so P is written as K into RT. Okay, K is K dash into RT, rather K dash into RT. What is K dash? K dash is intrinsic camera matrix of this right camera. And RT, R is for rotation, T is for translation. So R is some 3 cross 3 vector and T is a 3 cross 1 vector. Okay, so that is P dash equals to K dash RT. Okay, so P dash is the whole camera matrix or the whole right camera projective matrix. K dash is the intrinsic matrix of the right camera. RT, R is for rotation, T is for translation. Okay, so actually that is how we write P dash. K dash into RT. K dash is one matrix, RT is another matrix. RT means, R means whenever we are talking R, that is a rotation matrix, and T, that is a translation matrix. Okay, so actually that is a multiplication of two matrix, K dash into RT. Now H, okay, H, how we find H? H is K dash R into K inverse. Okay, I just shall I get the recorded version of the session till, yeah, you can get the recorded version in that YouTube channel, right? Everyone know, right, where you get the links and all? Everyone know those links, right? So let me give you, in case someone is joining. Yeah, so there are 3 links. This is my YouTube channel link. Whatever I am saying now, this will be recorded and will be provided to you in a YouTube channel. So this is link of my YouTube channel. Similarly, this is the link of the drive, okay, drive folder, in which I will be giving all those presentations, okay, presentation that I am showing, as well as some computer vision books, as well as some codes, as well as you guys asked me that regarding the full description of the previous assignments that are released, okay, so that those also I have kept in this folder. And third, there is a master link, okay, this also you should know. This is the, sorry, This third is the link of third is the master link, where you will get content of all the TAs, not my, but all the TAs. Three TAs are taking the course, so my content as well as the other two TA content you can get in the third link or the master link. So this three link you always save it, okay? So these are the three links. So in the first link, that is the link of my YouTube channel, whatever I have told, that I will be that I am already recording and I will be providing you in that YouTube channel, okay? So this is regarding this. Okay, so what I am discussing, I was discussing, so H, okay, H is the homogeneous matrix that transform X to X dash, okay. So H is given by K dash R K inverse, okay. K dash R will be coming from your right camera projective matrix. K inverse will be coming from your left camera projective matrix, okay. Otherwise, what you can do, if you are not given your projection matrix in this form, that is K dash RT or Ki0, so then what you can do is you can find your H by M dash M inverse, okay, M dash M inverse. So now can anyone tell what is M and what is M dash? Sorry, what is M? Rather, what is M? Can anyone tell what is M? Okay, no response. So in the previous class, what we have learned, so that is the formula of H, okay. H can be written like this also. If your this P and P dash is not given in this form, then you can write it as M dash M inverse. M is nothing but whenever you are writing any P, so how you write any P can be write as M and P4, right? That's how you can write it, M and P4. So any P, if it is even not in this form, then also any projective matrix can be written by this, okay. M is nothing but first three column of your projective matrix. P4 is nothing but the fourth column of your projective matrix. So if your P and P dash is not given in this form and it is given in normal matrix of normal 3 cross 3 cross 4 matrix, so how you can write or how you can find your H can be given there by M dash M inverse, okay. Now as it is given in this form, so that is why you can write it as K dash R K inverse H, okay. So this is the second important formula. Now third important formula is F, okay. F is found out by Ex H pi. Ex is nothing but E dash X H pi. E dash X is nothing but your E dash only, but E dash means your right epipole only, but E dash in skew symmetric form, okay. That is why we are writing E dash X. H pi is nothing but we have just discussed regarding that homogeneous matrix. Okay, someone is joining. Yeah. So this is regarding F, okay. That is the fundamental matrix. So we got this X, we got this X dash, we got this H, we got this F also, okay. And L dash is very simple, that is E dash cross X dash. That is how we can find. Now what is L dash? L dash is nothing but F into X. That is the fundamental matrix into your left image point. So that is F into X, fundamental matrix into left image point, that will give your right epipolar line, L dash. Okay, so these are the 3-4 formulas that are of major importance till now. So is it clear to all of you? Any doubt regarding this? You can ask. No doubt, right? Okay, no problem. Okay, nice. So let me proceed in the next thing, that is the essential matrix, okay. So fundamental matrix, how we can find the fundamental matrix? Okay, now your camera matrix was earlier in the form PKI0, okay. KI0, I means identity matrix and 0 means is nothing but a 0 column vector, right. P dash is given by this K dash RT. Now let's say that K equals to I. If K equals to I, that means we don't have any intrinsic okay, yeah, we don't have any intrinsic right, left camera matrix. We don't have K, but in place of K we have I. That means we have a identity matrix in place of K, and other things remaining same. In that case, your F can be given by this formula, that is mx into m. Again, what is m? Mx is nothing but your third row of your fundamental matrix, and capital M is nothing but this thing. Okay, so that is how you can okay, sorry, so here let me show you here. So yeah, so if yeah, this k dash rt can be written by this m, capital M and small m. Okay, now capital M is this, and small m is this m. Small m is nothing but your, for your translation, capital M is nothing but your 3 cross 3 matrix or the rotation matrix. So this, whenever you will do the multiplication, then you can get the fundamental matrix if your K value is I, that is the identity matrix. Okay, so this is case 1. Okay, this is the first case. Now we have the second case. What the second case is indicating? Second case is indicating is now we have K dash also equals to I. If our K dash is also equals to I, in that case your fundamental matrix get transformed into a matrix known as essential matrix, and that is given by Tx into R. Is the translation into the rotation matrix. That means this, only this, Tx into R. So that is how we write the fundamental matrix and essential matrix. Again I am repeating. So earlier your F is given by nothing but E dash into H pi. Okay, E dash x into H pi or H, whatever you tell, E dash x into H pi. That is how we are writing our fundamental matrix. Now there are two special cases to it. First special case, when K equals to I. Earlier we have some value of K, but in this case if K equals to I, if K equals to I, then our fundamental matrix will be converted to mx into m. Okay, mx is nothing but this part, that is the 3 cross 3 matrix, and small m is the last row of the 3 cross 4 matrix. Okay, so that is how we can write your fundamental matrix. But again, this is mx, that means your small m, that is the last column of your p dash matrix, that will be converted into a skew symmetric matrix before you do this multiplication. So that you have to understand. Now there is a second case. In our second case, K dash is also equals to I. If K dash is also equals to I, this value is also deleted. So we are only remaining with this RT. Okay, that is the rotation and translation. In this case, your fundamental matrix will be equal to Tx into R. In this case, in the second case, your fundamental matrix is known as essential matrix. So this is the theory. So now is it clear to all of you? This portion, we have two special cases. First case, if K equals to I. If K equals to I, then F will be equal to m small m x into capital M. If we have this second case, in second case K equals to I as well as K dash is also equals to I. In that case, our fundamental matrix will be equal to Tx, that is the translation, into the R, that is the rotational matrix. Okay, and in this case, second case, our fundamental matrix is known as essential matrix E. Okay, so these are the two special cases regarding our fundamental matrix. So is it clear to all of you? Is it clear? Yeah, please. Yeah, you can ask, please. Any doubt regarding this? So again I am repeating nothing. We have this two cases. One is K equals to I. In that case we have this fundamental matrix small m into capital M. Okay. Second case, K equals to I as well as K dash equals to I. In that case our fundamental matrix is T into R. Okay. In the second case our fundamental matrix is also known as essential matrix. So this is the simple thing. Okay. Now let me move forward. Yeah, let me move forward. We have this question. Let me delete this to have more space regarding this. Yeah. So this is our question. This is our question. So consider the following stereo imaging matrices. P is given, that is I0, and P dash is given. P dash is given by this. Okay, P dash is given by this. Compute the fundamental matrix. So can anyone tell which case will be this? First case or second case? Case 1 or case 2? Can anyone answer? It will be case 1 or case 2? No response. Is the question visible to all of you? Is the question visible? Am I audible?
Yes, sir. You are audible and the question is visible, sir.
Yeah, question is visible, right? So which case? Case 1 or case 2?
Sorry, sir. I joined late, so I couldn't answer. I am not the right person to answer.
Okay, so yeah, case 1, right? Yeah, very good. Case 1, because k equals to I, that is the identity matrix, right? But k dash is not equals to I, so that means first case. So if first case, what will be our answer? Our answer, fundamental matrix, will be given by small m into capital M, right? So what is small m? Small m is 481. What is capital M? Capital M is 346 872 152. So these are the two matrices. Now as your first case, it will be mx, right? So that means your m will be converted to your skew symmetric matrix. So how your matrix get converted into a skew symmetric matrix? For example, you have this matrix, right? Vx, Vy, Vz. Now how we can write it as Vx? V is this. How we can write it as Vx? So what you do is, you take the first element, right? Vx. Okay, so in the first element, first row, what you will write? In the x position, you put 0. Similarly, in the second row, as Vy is there, in the second position, you write 0. As Vz is there, in the third position, you write 0. Okay, so this is the thing regarding the diagonal. Okay, now what about the other elements? So other elements in the first row, what you do, the remaining, you have two elements, right? Vx is 0 in the first case, so you have Vz and Vy. So always write the second term first. Okay, so that is why write Vz here first. Okay, so that is why minus Vz, not Vz but minus of Vz and Vy. Similarly, in the second case, you have Vy equals to 0, but you are remaining with Vz and Vx. Okay, so now how you will write? You will write Vz into minus Vx, because this is the second row. That is why the sign is changed. So that is why you have to write minus in the second term. Similarly, how you can write the Vz? For Vz is 0, that means Z element is 0, but you are left with two elements, that is Vx, Vy. So in case of Vy, how you will write? You will write first Vy and then Vx, right? Vy and Vx. Now first element you will write minus and second element you will write plus. So that is why how you can convert your V to Vx. Similarly, you can convert your small m to mx. Okay, so how you can convert your small m to mx? So earlier what you have, this is your small m, right? 481. Okay, this is your small m. Okay, and this is your capital M, this portion is your capital M, and this portion is your small m. Okay, this portion is your capital M and this portion is your small m. Okay, so small m, how it can be converted into small mx? It is very easy, right? So you have 481. So this will be 0, this will be 0, this will be 0. In first you will write minus 1 8. In second you will write second 8 is 0, but you are remaining with 4 and 1. So you will write 1 first and then you will write 4. But in 4 you will be putting minus, because this is the second row. In third row again you will follow the same sign convention as the first row. How you will write? In the place of 1 you will write 0, so you will write left with 4 and 8. You will always write 8 first and then 4, so 8 4. And sign at first you will write minus and second you will write plus. So that is how you can convert your m to mx. Okay, So once your m is converted to mx, is very easy. You just do the mx into m. So this cross this or this multiply by this, you will get the fundamental matrix this. Okay, that is F. So is it clear to all of you? Is it clear?
Yes, sir.
Clear, right? Any doubt? Anyone, any doubt? You can please ask me. No doubt, right? Yeah, clear. Nice. Okay, so this is regarding the first question. Now let's move to another question. This is the second question. Consider the following stereo matrices given by P and P dash. Okay, this is the P, this is the P dash. Now you please note that in this theory part, whatever we have discussed, our matrix is in the form Ki0 and K dash RT. So, but here our matrix is not in the form of Ki0. Okay, if our matrix is in the form of Ki0, our last column will be 0. But as the last column is not 0, definitely our matrix is not in the form of Ki0. Or this can be form of K dash RT, but this is not in the form of Ki0. That means this H formula we cannot put directly. Rather, we have to use this H formula, that is H equals to what I have told you, that will be m dash, okay, m dash m inverse, okay, m dash m inverse, m inverse from this m dash m inverse, okay, m dash from this K dash R m dash, and m inverse from this K inverse, okay. So that we can do. Now here how we will do, and then we have to compute the fundamental matrix. How we can compute the fundamental matrix? It is very easy. That will be E dash H pi. Okay, so once if we get the H pi or H, we can just multiply with the E dash, and we can get our fundamental matrix, that is F. What is the second question? Given an image point 15, 20. Okay, the reference camera P, that means this is the left image point. Compute the epipolar line and its two endpoints of P dash. So epipolar line in the another image plane, that is very easy. That is given by this formula, right? L dash is nothing but F into X. Once we have this X has already been given. We have this F. Definitely we can find the L dash. Okay. So again it is very easy. So now let's move on to the solution. So I have told you what you do. You convert this P to small m, capital M, small m, and you convert this P dash to capital M dash and small m dash. So that is what we have done, or rather we have written like this, capital M, and P4 can also be written as small m. Similarly here m dash, and this can also be written as a small m dash. Okay, so that is how we can write. Now how we can find this? How we can find this F? F is can be found by E dash X H pi. Okay, so before moving to H pi, we have to find the E dash. So to find the E dash is very easy. E dash is given by this formula, right? E dash is given by E dash is nothing but the image of the camera center of the left camera center by the right camera, right? P dash is for the right camera, and C is the center of the left camera. So so E dash, or the right epipole, is the image of the left camera center found by the right camera. That is the definition, right? So P dash, we have this P dash, we already have this P dash. If we have this C can be very easily find out. This is also we have read in the previous class. C dash is nothing but minus M inverse P4. So M we have this P4. You just find out this M inverse, and you just multiply it with by P4, and you will be get the C tilde. C tilde is nothing but, that means in inhomogeneous coordinate. In homogeneous coordinate, what you have to do? You have to just add a 1 here, or just add a scale here. So just add 1 here, and you will be converting this C delta to C. Okay, so once we get C, we have P dash, so we will be getting the E dash. So our one portion is complete, right? E dash portion is complete. Now once E dash portion is complete, we will be finding the H pi or H whatever. Okay, So h can be very easily find out by m dash m inverse. So m dash, we have this m in dash and we have m, and we can also do the m inverse, that we have already done. So m dash m inverse, just multiplied, we are getting this. So f is nothing but e dash x h pi. So e, yeah, again e dash is found in this form, but again you do the previous thing that I have told you. You convert this e dash to a skew symmetric matrix first, and that this is the skew symmetric matrix, and then multiply it by h or h pi, whatever you tell. E dash into h pi is nothing but your fundamental matrix. So you will be forming your fundamental matrix. Okay. And what about the second question? Second question, second question is very easy. L dash is nothing but fx, right? So L dash you can easily find out, that will be nothing but your f into x. Okay, so L dash is fx, so f is already we find out in this part, and x is already given, that is 15, 20, and you have to put 1 here because this is a inhomogeneous coordinate, but to put it in homogeneous coordinate we have to add scale here, so that is why 1. So L equals to f into this image point. Okay, so that is why, that is how you can find the L dash, not L, rather you can call it as L dash because it is rather the right epipole, so you can call it as L dash. Okay, L dash is f into x. So f into x, you can find this. And second thing is compute the epipolar line of its end point of end image points of p dash. That means whatever the epipolar line that will be formed L dash, okay, you just found the end points of this epipolar line. So that how you can do it, it's very simple. You just multiply you just multiply this what do you call this homography matrix into your image point that is given 15, 20. So by that you can get nothing but your two end image points of p dash. Okay, so two end image point of p dash are 5.27 and 5.11. This is nothing but for scaling. Okay, this is nothing but for scaling. So by that you can find the end point of your epipolar line L dash. Okay, so that is how you can solve the question. So is it clear to all of you? How to write V matrix? V matrix means skew symmetric matrix, right? Skew symmetric matrix, yeah. Okay. So let me tell you the trick. So you have like this capital X. Okay, capital X is given by, let's say, small x, small y, and small z. Okay, now you have to find x, that is the skew symmetric matrix of this capital X. How we will write it? So now it will be converted. Earlier it was nothing but your 1 cross 3 or 3 cross 1, whatever you tell. Okay, so actually it is 1 cross 3 here. Okay, 1 cross 3. Now we will be converting it to 3 cross 3 matrix. Now will be converted to 3 cross 3 matrix, because then only we can have a skew symmetric matrix. Then only we can have a skew symmetric matrix. So x, y and z are the 3 elements. So x will be taking the first column, you can understand like this. Y will be taking the second column, and z will be taking the third column. Virtually you can understand like this. So
column or row, sir?
Sorry, rows. Okay, x will be
You're writing row and speaking column.
Yeah, row.
Thank you, sir.
Yeah, x will be taking the first row, y will be taking the second row, z will be taking the third row. That's how you can remember. So whichever row it is taking, you put 0 here. Okay, because x is taking the first row, so you put 0 here. Y is taking the second row, you put 0 here. Z is taking the third row, you put 0 here. Now what you have left with, if in the first row have already deleted x, or you have put 0 in place of x. What you are left? Y and z. So always write, if you have y and z, always write the z first. Okay, always write the z first and then y. Okay. Now in second case you have y equals to 0, right? Y equals to 0. Now you are left with x and z, right? So always put the second element first. So z and x. Okay. Now in the third row we have put the z0, so we have x and y. So y and x. Okay. Now think about sign. Sign, what you do in the first row, you put negative here. In the second row, actually the sign is always interchange in the second row, so that is why you put minus here. In the third row again you put the minus at the first position. So that is how you convert your capital X to skew symmetric matrix XX. Okay. So is it clear? Clear, right? So now you can convert your E dash to E dash X, right? Now you can do it, right? Okay, nice. So what about the rest of the question? Is it clear to all of you? Is it clear? Any doubt? No doubt, right? Okay. I am assuming no doubt. So let's move on to the next things. So there are some properties of the fundamental matrix. Okay, so we will learn this. Okay, so first thing is this property. Okay, that is x dash t f into x will be equal to transpose of xt, transpose of x, transpose of fundamental matrix, and sorry, x dash. Okay, that will be equal to 0. So this is the first property. Okay. Second, we have this property. If f is the fundamental matrix of p dash, then ft, or transpose of f is the fundamental matrix for p dash p. Okay. So this is the second property. Someone is joining here. So this is the second property. Now third property regarding this epipolar lines. So L dash is given by f into x, right? Similarly, L is given by f of t into x dash. Okay, this is the third property. Now we have this fourth property, or another important property. So that state that f into E is equal to 0. F is the fundamental matrix and E is the left epipole, right? So that is why E is the left epipole, also known as right null vector of F. Similarly, we can write like this. Okay. So this, if we do the transpose of it, then it will be equal to f of t, that is the transpose of f. Okay, and E dash equal to 0. F of t, that is the transpose of fundamental matrix, into E dash is the right epipole, that will be equal to 0. So this and this, Fe equals to 0. So E dash is also known as the right epipole, also known as the left null vector of F, and E is the left epipole, also known as the right null vector of F. Okay, so these are the three properties. So again I am repeating, this is the first property. Okay, this I don't think there is much use of this. This is the second property. If f is the fundamental of p dash, then ft is the fundamental property of p dash and p. Then this is the third property. This is important. L dash equals to fx and L equals to f of t into x dash. Okay. Similarly, this third property, this fourth property, this is again important. That is ft into E dash equals to 0 and f into E equals to 0. So this is the regarding the epipole property. Now we are left with the last property, that what is the degree of freedom of the fundamental matrix. So fundamental matrix is nothing but a 3x3 matrix, right? 3x3 matrix. So we will have 9 total elements. Now out of 9 total element, what we know, one element always go for scaling. Okay, so 9 minus 1 equals to 8. So 8 should be the degree of freedom. But one of the important property regarding fundamental matrix, when we always say that determinant of f or det f, that will be equal to 0 always. So as determinant is equal to 0, so again we have to do 1 minus, so our DOF will be 7. So ultimately you have to remember that fundamental matrix has a degree of freedom 7. Okay, so these are some property regarding the fundamental matrix. Okay, now let's do one question or one or two question that will be more clear to all of you, okay, regarding the properties. Okay, so this is the third question of our third question of the exercise. Consider the following fundamental matrix. This is the fundamental matrix already given. So given 2 point 5 comma 8 and 7 comma minus 5 in the left image. Compute the corresponding epipolar lines in the right image. So very easy. So if we have 2 point x and x, you say that is in the left image. So let's say x1 and x2. So very easy to compute the L1 dash and L2 dash. That is very easy by this property, right? L dash equals to f into x. So L1 dash will be equal to f into x1. Similarly, L2 dash will be equal to f into x2. So that is very easy. So this is regarding option A. Now compute the right epipole. Right epipole is very easy. How we can find the right epipole? Right epipole can be found out by this formula, ft into e dash. Ft we already know, f we know, then we can do the transpose of it. We can find the ft, and e dash. E dash we can assume an epipolar point like xy1. Okay, so xy1 we just multiply with the ft, and third row is actually we don't want because we have only two important points, right? Because e dash will be x comma y comma 1, because it is nothing but it is a image point only. Okay, so that is why e dash will be written as x comma y comma 1, or you can write it as er1 er2 1. Okay, so that is why only two rows are important. Third row is even not important. The third row is 1 is there, so that is the third row is even not important. So by this two row or ft, you can say first two columns, okay, we can get the e dash. Okay, similarly, how to get the left epipole? Left epipole is given by this f into e. F we already have. E can be written as el1 el2 and 1. So el1 and el2 we can find out and we can get the answer. So let me show you what I am indicating. So first is very easy. This formula, L dash is f into x. Very easy. So f, we have been given f into x1. If we can get L1 dash, and f into x2, then we can get L2 dash. Okay, so this is very easy regarding the regarding this epipolar lines. Okay, now about b, that is again very easy. I have told you that will be given by ft dot e dash. E dash we are assuming e dash as er1 er2 1, and f dash ft dash, sorry, ft is nothing but this, f is our this, so ft just do the transpose of it. So 28 4 is our first row, 12 minus 7 33 is our second row. Okay, so just take this two row and take this matrix, and we will get two equation, two variable we can easily solve, and we can get our er1 and er2. So er1 er2 means we can get the e dash. Similarly about similarly about left epipole is nothing but f into e equals to 0. So f we have this, and we will again take the first two rows. So take the first two row and write your left epipole as el1 el2 1. Two equation, two variable, we can solve it and we can get the left epipole. So this is the question regarding fundamental matrix properties. So is it clear to all of you? Any question regarding this? You can please ask. No question, right? Properties are very clear. So two important properties here, L dash equals to fx, or rather you can again, if you are given L, to find L, that is ft t into x dash. Okay, and second is regarding epipole, that is ft e dash equals to 0 and fe equals to 0. Okay, so these are the two properties by that we can solve this question. Okay, so I hope no doubt regarding this question. So any doubt you can ask me, no problem. Any small doubt you can ask me. No doubt, right? Okay. So let's move on to the next thing, that is essential matrix property. Previously we have discussed about fundamental matrix property. Now we will be discussing about essential matrix property. Okay, so essential matrix property. So essential matrix, so how many parameter will be of essential matrix? So essential matrix is written by this form, right? E equals to tx r. Okay, so tx will have 3 parameter and r will also have 3 parameter. So our essential matrix has actually 6 parameters. Okay, essential matrix has actually 6 parameter, and one parameter we always do one parameter for scaling. So our essential matrix will have 6 minus 1 equals to 5. That will be the degree of freedom of our essential matrix. So in fundamental matrix we have 9 parameters, or 9 minus 1, that is for scaling, and minus 1 for, as your f will always be equal to 0. So that is why determinant of f will always be equal to 0. That is why our degree of freedom of a fundamental matrix is 7. Here we have essential matrix, we have 6 parameter, 3 for translation, 3 for rotation. So that is why we have 6 parameter in total, and 1 we always do for scaling. So that is why our essential matrix will have 6 minus 1, that is 5 parameter, or 5 will be the DOF of the essential matrix. Other property you already know. This property you already know, how we can get the essential matrix equals to tx into r. So this is what you need to understand. Now there is a case regarding pure translation. Okay, pure translation. Pure translation means in the second matrix, we have earlier we how we write this matrix. Earlier we write it is k dash r k inverse, right? E dash dot h. Okay, h is written by nothing but your k dash r k inverse, right? K dash r k inverse. So here, as it is a case of pure translation, so r will be nothing but r will be equal to I. R will be equal to I. So now our h will be written as k dash I k inverse. As I you can write, you cannot write, so you can directly write it as k dash k inverse. Okay, so k dash k inverse. Now for k equals to k dash, if you have k equals to k dash, then k equals to k dash, and that will be equal to I. If this is the case, then what will happen? Your f is nothing but e dash x. Okay, so this is the whole theory behind it. So again I am repeating, first case is your r is no translation only, sorry, no rotation, only translation. So that means r will be equal to I. So your h will be equal to k inverse. Now there is another case where k equals to k dash equals to I. Okay, in that case what will happen? If k equals to k dash equals to I, your f is nothing but e dash x. So these are the two things you need to understand. Now there is a one major thing, that is computing depth. Okay, to compute the depth. To compute the depth, what you do is, in order to compute the depth, there are two cases. One is regarding this pure translation. Pure translation means here you have no r. Okay, here you have no r, rather you have I, because rotation is, there is no rotation, so here you have I. So you have this first camera matrix p k I 0, and second camera matrix that should be k dash r t, but as it is a case of pure translation, so that is why you have k dash I t. Okay, so in this case, to compute the depth, you have to understand, or you have to rather remember this formula, that is z equals to kt x minus x dash. Again, k is always written in this form. If there is no, you can say there is no no offset of principal axis, that is there is no px py, then k is written in this form. So in this case your z can be written as this, z equals to f tx x dash minus x. Okay, so that is how you can compute the depth. So this is again a very important formula. Now in case that your r, it is not a case of pure translation, so you have r here. So if you have r here, then this z formula or depth formula is converted to this, that is k dash t divided by x dash minus k dash r k inverse, that is nothing but your h matrix. Okay, h matrix or h pi matrix into x. Okay, so this is this form. So if in case of pure translation, then it is very easy. If it not a pure translation, you have to do this, that is k dash t. K dash is nothing but k dash is your this matrix. Okay, k dash t, you have to first do k dash t and divided by x dash is already given, because x is, the x dash is already given. Similarly x is also given, so x dash x is already given, so minus k dash r k inverse. So by that you can do the you can compute the depth. So again these two are very important formulas. Okay, so by this you can solve all your questions regarding your assignments. So is it clear? Computing depth, what are the two formula you need to understand? One is z equals to this kt x dash minus x, and second is z equals to k dash t x dash minus h into x. Okay, or rather you can say x dash minus k dash r k inverse x. Okay, so these are the two formulas. So are all the formulas clear? At least you can understand the formula. If you can understand and remember formula, you can solve all the questions. Okay, so by this we will be starting our question answer session. Okay, so okay, so exercise is also there, so let's solve this first. Yeah, so consider a stereo setup with p and p dash camera matrices for left right camera as given. P and p dash is already given. Okay, so you can see here it is of the form k ki0, right? Ki0, ki0, this is I and this is 0, because last column is 0, so this can be written as ki0. Okay, and this can be written as k dash I into t. Okay, k dash it, because here you can see that 0 is not there, the fourth column is not 0, but rather there is a translation here, so that is why it is k dash I, because again I, because there is no rotation here or the translation, and you have this t, this can be written, you have this t. Okay, this can be written like this. So p is this ki0 form and p dash is in k dash I t form. So very easy like this. So we have to apply this or this, same thing, this or this we apply, and we can get the corresponding depth. Okay, and x and x dash is also given here, x and x dash is also given here, so we can easily compute the depth. So very easy, p is k in the form of this, p dash is in the form of this. So in this what we are interested, z is given by this formula, right? Z is given by f tx x dash minus x. So we have f is given, f is 6, you can easily see in this this as well as this matrix, f is nothing but f is 6, right? F is 6 we know, and then we have this f into tx, right? Tx is also known, that is 10 by 6. So x 6 into 10 by 6, so let me write it, f into tx, f into tx, f into tx, f into tx by x minus x dash. So f is nothing but, f is 6, what is tx? Tx is 10 by 6 divided by x minus x dash. The coordinate here is 6 and here is 9.33. So x minus x dash you can compute, that is 9.33 minus 6, or whatever, you do the mod of it, because you all know that distance it can be, it is always written in modulus form, so that is why you do 6 minus 9.33 or 9.33 minus 6, whatever you do, just do the mod of it and you will get the answer. Your answer will be 3. Okay, So your answer will be 10 by 9.33 minus 6, that is 10 by 3.33, that is approximately equals to 3. So Z will be equal to 3. So simple formula, just put the values and you will get the answer. Okay. Now we have this last thing, that is estimation of fundamental matrix. Someone joining. Yeah, estimation of the fundamental matrix. So estimation of the fundamental matrix, I have already told you. So a fundamental matrix is nothing but a 3 cross 3 matrix, and one value we always do for scaling. Okay, one value will always do for scaling. Now we will be using this formula. Okay, x dash t f into x will be equal to 0. By this formula we will be getting how many equation? We will be getting 9 equation. Okay, we will be getting an 9 equation, but our f33 is always equal to like 1, so that is why we will be getting 8 equation, and our degree of freedom is also 8. So that means we will be needing minimum 8 point of correspondence for the estimation of the fundamental matrix. Okay, because one f33 we always do it 1, that is we always keep it for scaling, so always we will do 1. So x dash x we will be needing how many? 8 correspondence, 8 point of correspondence to compute this f matrix or the fundamental matrix. Okay, so this is regarding the whole theory. So is the depth formula clear to all of you? This is last thing is just for theory, but is the depth formula clear to all of you? F tx x minus x dash. Okay, when your p is in the form of ki0 and p dash is in the form of kit, that is pure translation, no rotation. Okay, so that is the depth formula. So is it clear to all of you, all the formulas? Clear, right? Any doubt in the formulas? Any formula you have any doubt? Okay, so by this we will be starting our session of the question answer. So the topics on which week 4 assignment are based: stereogeometry, epipolar geometry, fundamental and essential matrix, properties of fundamental and essential matrix, computing depth, and estimation of the fundamental matrix. Okay, so let's solve this question. Given the right epipolar point E dash is given and the point X dash is given. X dash is nothing but your image point in the right image plane. Okay, of a stereo imaging setup, compute the epipolar line L dash containing the point X dash in the right image plane in homogeneous coordinate system. So we have E dash and we have X dash. So can we find the L dash? E dash and X dash. This is E dash, we have X dash. So can we find the L dash? Can we find it? Can anyone answer how we can find it? L dash with E dash and X dash. Can anyone tell? Come on, we have 2 points and we want to form a line from these 2 points. How we can form a line from 2 points? This we have studied in the first class, right? 2 points, how to form a line from the 2 points? Am I audible? Hello, am I audible? Yes, I am audible, right? So how to get a line from the 2 points? We have point x1 dash x, yeah, just do the cross product, right? So we can just do the cross product of E dash and X dash and we can find the L dash, right? Very easy, right? So I hope this is clear to all of you. E dash cross L dash cross X dash and we can find the L dash. So L dash will be equal to E dash, this is E dash, okay, E dash cross X dash. E dash cross X dash. So very easy. So this is how we will find out. L dash will be equal to E dash cross X dash. Very easy. L dash E dash cross X dash. Just do the dot product. How we will write? L dash ijk, okay, ijk, E dash you will write 2 3 1, X dash you will write 5 2 1. So L dash ijk 2 3 1 for E dash, 5 2 1 for 5 2 1 for X dash. So just do the cross product and we are getting this 1 3 and minus 11, 1 3 and minus 11. So 1 3 and minus 11. You just normalize it because I think coordinates are given. Yeah, coordinates are given with 1 or minus 1 here. So just divide it by minus 11, and when you divide it by minus 11 you will get the answer in the homogeneous coordinate. Okay, that is minus 0.0909 and minus 0.2727 and 1. So option D is your correct answer. So is it clear to all of you? Clear, right? Very simple question. Any doubt for anyone? You got the concept, right? Why we are doing L dash equals to E dash X dash? Because L dash is formed by this 2 point, E dash and the X dash. E dash is the epipolar epipole point or right epipole point, and X dash is the right image point. So by this two you can just do the cross product and you can get the right epipolar line. Okay, so this is very simple question. Now let's move on to the next question. Assume that a stereo imaging setup has this two image planes, left and right. Okay, which of the following could be possible right null vector or the left epipole for the corresponding stereo image setup? F equals to this. F is given, so you are asked to compute the left epipole. So what should be the formula for this? You have F, you have to compute the left epipole or E. So what is the formula for this? Anyone? What is the formula for this? Come on. We have discussed, right? There are two formula, right? Fe equals to 0 to compute the left epipole, and Ft E dash equals to 0 to compute the right epipole. So to compute the left epipole here, it is very easy. F into E equals to 0. So F is given, E we have to assume like EL1, EL2 and 1. By this we can get the two equation, and two variable EL1, EL2, so we can get the left epipole, right? So let me show you. Yeah, so F E equals to 0 to compute the E is the left epipole or the right null vector of F. Okay, so we can easily calculate this. Okay, easily calculate this. Let me keep it here. Yeah, so easily calculate this E. Let's take E as E1, E2, or rather EL1, EL2, because E is the left epipole. Okay, so we have this point and we have this F, and we can get two equation because this line is rather not productive, because this line does not make any sense because here 1 is there. So we have two variable, and by this two equation only we can get the answer, or E1 or E2 variable. So very easy. First equation will be this and second equation will be this. So just solve it and you will get the answer. Okay, you will get the answer, that is minus 3 comma 5 equals to 1. That means E1 is minus 3, E1 is minus 3. Where is E1? E1 is minus 3 and E2 will be equal to 5. Okay, E2 will be equal to 5 and you will get the answer. So minus 3 5 comma 1, minus 3 5 comma 1. So option C is your answer. Okay, option C is your answer. So is it clear? Is this question clear to all of you? Clear, right? Any doubt? Others, you can please ask me. Any doubt? No problem. Small to small doubt you can ask me. So you understood, right, how we got the two equation? By multiply F into E. Okay, F into E equals to 0, we will get two equation. Okay, two equation, we will actually get three equation, but third equation is of no use because we have only two variable. So two variable, two equation, and we can easily solve the two variables. Okay, so I hope this is clear to all of you. Okay. Now this are the information for question 3, 4 and 5. So consider a stereo imaging setup. We have K and we have K dash. This is the left intrinsic camera matrix. This is the right intrinsic camera matrix. We have R. Okay, R is the right. R is the rotation. Rather, you can say R is the rotation vector for this right camera matrix. Okay. Now based on the given parameter, solve the question 3rd, 4th and 5th. So find the homography matrix. So what is the formula for a homography matrix? If you have K, K dash and R, can anyone tell what is the formula?
So can you please go back to previous slide once?
Previous slide.
Yes.
Okay.
Yes.
Okay. We have K, we have K dash, we have R. Okay. So what is H? How H is computed if you have K, K dash and R? What is the formula of this? If we have K, K dash and R? Multiplying all the three matrices. Yeah, what is the formula? Three matrix is okay, but what is the order? H equals to K dash R K inverse, right? K dash R K inverse. So these are the three matrices, but our H is computed by this K dash R K inverse. Okay, K dash R K inverse. So K dash is given. Okay, K dash is given, R is given, but K inverse is not given. We are given K. So first we have to find the inverse of this K. Okay, once we find the inverse of this K, then we can multiply. That is K dash into R into K inverse. Okay, rather first you can multiply this two, any two you can multiply. You can just multiply K dash R first and then you can multiply with this K inverse. Okay, so that you can do and you can get the homography matrix or H, that is 1 1 3 coming, 1 1 3 0 1 1 0 1 1 and 0 1 0. Option B is the answer. Okay, option B is the answer. So is it clear? Is it clear to all of you? Clear, right? Okay, nice. Multiplication, you can multiply any two first. Okay, you can multiply this two first and multiply with this, or you can multiply this two first and multiply with this. Anything you can do, just maintain the order. Okay, just maintain the order. So better you have K dash R. So first you multiply this two first and then multiply it by K dash. Okay, and you can get the H. Okay, that you can do, that is best. Now given the translation vector T as 1 0 1, compute the right epipole. So can anyone tell how we can compute the right epipole, that is E dash? How we can compute E dash? What is E dash? E dash is P dash C, right? E dash is P dash C, right? Yeah, E dash is P dash C. So P dash C is okay, but P dash, how we can compute P dash? P dash is not given, right? What is given? We are given K dash and R is given, right? And now we are also given T. So K dash RT is nothing but your P dash. Once we have P dash and we have this C, right? What is C? C is nothing but your C is nothing but C000 we can assume. Okay, C000 yeah, 000 we can assume because nothing is given regarding C. So C000 we can assume, and in homogeneous coordinate 0001 we can assume this and just do this, that is p dash c, right? P dash, so c we already have. Now what we have to find is p dash. P dash is nothing but, I have told you, p dash is nothing but k dash and rt, right? rt, square bracket, okay, this is square bracket. So this is p dash, okay. K dash, we are given k dash, we are given r, we are given t. So rt matrix we can form. R is already given. What is the R matrix given? So R is given 1 0 0 0 0 1 and 0 1 0. Okay, R is given, and T is also given. What is the T? T is given as 1 0 1. So we got this matrix, and we already got this matrix, that is K dash. So P dash we can easily compute, and once we have P dash, we have C. So just multiply P dash with C, and we can get the answer. So here the thing is, as C for our C is 0 0 0 1, because this is the center of the left camera. So that is why, as this is the case, so that is why our rotation will, there is no effect of the rotation, because rotation will take this 3, right? So there is no effect of rotation, so that can be written as k dash t. So even if you don't understand this, just do this, okay? E dash is nothing but p dash c. You have p dash, I have already told you have p dash, that is k dash rt, and you have this c is 0 0 0 1. So you just multiply this and you will get the answer. So is it clear? E dash is p dash c, right? So what is E? How you can find E? Can anyone tell how we can find E? If E dash is p dash c, how we can find E? That is the left epipole. This is the right epipole, right? E dash is p dash c. Now what is E? What is the formula of E? Yeah, E is p c dash. Yeah, exactly. E is p c dash. So P, we already have P, right? We have P or no? So let's see. We have P, because P is nothing but K I 0, right? So K we have, I we know 1 1 0 0 0 1 0 0 0 1, and 0 is 0. So we have P, we have C dash. If we have C dash actually we do not have at this moment, but C dash, if we have C dash, we can easily calculate this. Even from this we can calculate C dash. C dash can be calculated by, as we have this matrix, okay? So C dash is nothing but what? R minus M inverse P4 for the right camera matrix, right? So by that we can compute C dash. Once we have C dash, we have this P, then we can compute the E, okay? E we can compute, that is P C dash. So is it clear to all of you? Okay, nice. Okay, nice. So let's move on to the next question. Compute the fundamental matrix F. So how we can compute the fundamental matrix? Can anyone tell how we can compute the fundamental matrix? What is the formula of fundamental matrix? F equals to E dash into H, right? E dash we already have in the previous question, previous answer, okay? H we have from the previous to previous question, okay? So it is very easy. So this F is E dash into H pi or H, okay? E dash into H. So E dash, only the thing is E dash you have to convert in skew symmetric matrix first. Once you convert in skew symmetric matrix, just multiply by H. H, we found H in this question, okay? H we have, this is the H we have. E dash we have found in this question, this is the E dash we have. We can just multiply, but thing is this is 3 cross this is 3 cross 1, right? This is 3 cross 1, and our this E dash into H. H is 3 cross 3, right? H is 3 cross 3. So if we directly multiply E dash into H, we will not get our answer, because this is not not multiplicable, right? Because 1 and 3 is there, this 2 should be same. For two matrices to get multiplied, this 2 should be same. That is why we have to convert this 3 cross 1 matrix into 3 cross 3 matrix, that is E dash X. So just convert it into a skew symmetric matrix first. So E dash is this, but we have to convert in this skew symmetric matrix first. Once we convert into skew symmetric matrix, just multiply it by H and we will get the fundamental matrix, that is this. Okay, so right answer is 0, 0, minus 2. Option D is your right answer, right? Yeah. Option D is your right answer. So is it clear to all of you? Clear, right? Okay, nice. Now let's move on to the next question. Given the fundamental matrix this, based on the given data, solve the following questions 6 and 7. So we are given a fundamental matrix, and based on this data, we have to solve the question 6 and 7. Given 2 points 5, 8, 7, minus 5 in the left image, compute the epipolar lines in the right image, right? So how we can calculate the epipolar line? If we have fundamental matrix and a point in the another image plane, how we can compute? L dash equals to what? L dash equals to, come on, L dash equals to F into X, right? So L1 dash equals to F into X1, L2 dash is F into X2. Okay? Clear, right? So very easy. L dash equals to F into X. So you are given X, right? 5, 8 and 7 comma minus 5. But this is in this inhomogeneous coordinate. So just put 1 to convert into a homogeneous coordinate, and then multiply it by F matrix. Okay. So F into X1 you will be getting L dash, L1 dash, and F into X2 you will be getting L2 dash. Okay. So L1 dash is coming 21, 13, 13, and L2 dash is coming minus 20, minus 22, 2. Okay, so option B is your right answer. Option B is your right answer. So is it clear? Clear, right? It is very easy property. Is it clear to all of you?
Sir, here, so output is 20. Okay, what is 21, 13, 13. Okay, got it. Thank you.
Okay. So if you are given X dash, okay, how you can get L? If you are given X dash, how you can get L? This we are given X, so we can find L dash. But if you are given X dash, how you can get L? This thing should be clear, so let me show you again this properties. I think you guys have some doubt regarding the properties. Okay, so these are the two properties, right? So this is the property we just use L dash equals to Fx. Now if we are given X dash, how we can find L? That is very easy. L equals to Ft X dash. Okay, so this is the property by which we can get L if we have X dash. Okay, in our question we have X, so we can have found L dash with this F into X. If we have X dash, then we can find L by Ft into X dash. Okay, so this is the thing. So what I told, is it clear to all of you? Clear, right? Okay, nice. Find the right epipole. Okay, right epipole, same thing. So I have already told you. Okay, so question number 6 and 7, right? Yeah, 6 and 7. Okay, so find the right epipole. So right epipole, either you can right epipole. So this you have find the right epipolar line. Okay, right epipolar line you have find out. But now what you have told, you have been told to find the right epipole. So right epipole can be given. You have two lines that is in the right epipolar point. Okay, so two lines. How you can get the epipolar point from the two line? You have two line. How you can find the intersection of this two line? Intersection of this two line is nothing but your you will get a point, right? Two line, by two line we get a point, by 2 point we get a line, right? So two line in the same plane you will get a point, and that point is nothing but your right epipole. So we have L1 dash, we have L2 dash. Just multiply this two and you will be getting E dash. So it is the concept of the first class, right? Two line, the intersection of two line will be giving a point. So just do the intersection of this two line. So we have in the previous question we have our line as 21 13 13 and minus 20 2 2, right? You just do the cross product of this two and you will find the E dash, or the right epipolar point. Okay, right epipole point or right epipole. So just do the cross product and you are getting 0 minus 302 and 302. 0 minus 302 302. Okay, so option D is the correct answer. So is it clear? Is the 6 7 question clear? Any doubt? So again let me repeat what was in the question. So we have been given a fundamental matrix. Okay, now what we have been told in the sixth question that we are given 2 point in the left image plane. Okay, and what we have been asked to find the epipolar lines in the right image plane. So epipolar lines can be computed, L dash can be computed by f into x. So we have been given x, we have been given f, so we can compute L dash. But we have been given 2 points, so we can compute 2 epipolar line. L1 dash also we can compute, that is f into x1, f into x1. L2 dash will be f into x2. So by that we can compute the L1 dash, L2 dash. In the 7th question, what have been asked? We have been asked to find the epipole. So epipole is nothing but the intersection of L1 dash into L2 dash, and that will be given by the cross product of these two lines. Okay, so this was the question of 6th and 7th. Now let's move on to the next question, that is question number 8. Consider a stereo imaging setup with two cameras. This is our first camera P and this is our second camera P dash. Okay, which of the following options are correct? F and the right epipole, F and the right epipole. Okay, so what should be the formula for this? If we have P and P dash, how to find the F? Yeah, and P is given by K. P is given by Ki0, right? P is actually given by Ki0. Yeah, P is given by Ki0. Or rather I can say even I0. K is also equals to I here, so rather I0. Okay, and P dash is given by something. Okay, that is RT you can say, KRT you can say. Okay, so how to solve this question? Okay, P dash is given, so to find the right epipole. Okay, right epipole is nothing but this formula, E dash equals to P dash C. That is the image of the left camera center will be the right epipole in the by the right camera. Okay, so E equals to P dash C. C, as this is the equation of this, so C is nothing but it is at the origin. Okay, C is nothing but it is at the origin. C is at the origin, P dash we know, so easily we can compute the E dash or the right epipole. So just do this, P dash into C, you do this and you will be getting the right epipole. Okay, that is very easy. Now about the fundamental matrix, you know you know very well how to compute the fundamental matrix. Fundamental matrix, if your k equals to I, then we have the first case, that is first special case. F is computed by mxm. Okay, so mxm. Okay, so what is this? M is this. Okay, 125.200.302. And what is small m? Small m is this 121. So just m, you do the mx of it, or the skew symmetric matrix, and you do the mx into m. That is m you already have, you just multiply with mx into m, you do, and you will get the fundamental matrix. Okay, so 121 is coming as the right epipole, so option B is right. And here 404 minus 223 and 0 minus 410 C. Okay, this is the fundamental matrix. So you got the right epipole, you got the fundamental matrix. Okay, so is it clear? B as well as C is the correct answer here. So is it clear to all of you? This is the first spatial case, right, where k equals to I. Where k equals to I, your f will be given by mx into m. Okay, mx and m is nothing but your p dash. Okay, but your matrix of p dash. P dash can be divided by mx or m. Okay, sorry, m and capital M and small m. Capital M is the first three column, small m is the last column, okay, of the p dash matrix. So by that you can easily compute the f. And right epipole is very easy. Right epipole is the image of the left camera center. So E dash equals to P dash into C. Okay, so P dash is already given. C is nothing but your as your P is the most simplest form, that is K I0, or rather I0. So your C is nothing but that will be origin point. So origin point you multiply by your P dash and you will get the right epipole. Okay, so clear, right? Okay, nice. This is clear to all of you, right? Any question regarding this question? Any doubt regarding this question? No doubt, right? Okay. Now question number 9, given the right camera, this is the right camera, rotation of the right camera rather we can say, and the translation is given T111, compute the essential matrix. So what is the formula of the essential matrix? Can anyone tell? What is the formula of essential matrix? Case 2 of the special case of fundamental matrix. First case is a fundamental matrix equals to small mx into capital M. Second case is where k dash is also equal to I. In this case, what is the fundamental matrix? That is the essential matrix, right? F equals to E equals to, anyone? Come on, it will be T x into R, right? It will be Tx into R. So very easy. T is given, so we can convert into Tx. Very easy. Tx we can convert. T is given, so we can convert into Tx. And R is also given. You just multiply Tx into R, and you will be getting your essential matrix. Okay, 0 1 minus 1 0 1 minus 1 1 minus 1 0 minus 1 0 1. Option C is your correct answer. So is it clear to all of you? This is the second special case of fundamental matrix, okay, where k as well as k dash will be equal to I. In this case, your fundamental matrix equals to essential matrix equals to Tx into R. Okay, clear, right? Okay, nice. Now the last question, that consider a stereo imaging setup with two cameras. This is the first camera, this is the second camera, P and P dash. If the image coordinate of the 3D points are 10 3 and 15 3. In the left and right cameras, compute the depth on the depth of the z coordinate in 3D. So this is of the form, actually this is of the form k I k I0. This is of the form k I0. This is of the form k I0, and this is of the form p dash is of the form k dash. It is k dash. Okay, this is k dash, and this is I only, because there is no rotation but pure translation I t. Okay, so when we have this, our z is nothing but f into tx, and divided by x minus x dash. Okay, so what is our x minus x dash? Okay, x minus x dash. So what is our f? F is nothing but 2. You can easily see f is nothing but 2. F is 2, and what is our tx? Tx will be 5 by 2, because whenever you will take k common, so f will be 5 by 2, sorry, tx will be 5 by 2, x is nothing but 10, x dash is nothing but 15. Okay, so your answer will be nothing but 2 into 5 by 2, that is 5, divided by 10 minus 15, that is minus 5. Okay, and we know that the distance or depth cannot be in negative, so that is why it will be 1. Okay, it will be 1. So 1 will be the answer. It is very easy. 5, it will be x dash minus x, or x minus x dash. So 5 by minus 5 or 5 by 5, it will be 1 or minus 1. So 1 is the correct answer, because depth is always in a distance, so it is a type of distance, so it will always be in positive. So your answer will be 1. So is it clear to all of you? Is it clear to all of you? Clear, right? So any doubt in today's class? Okay, no doubt. So let me show you this code. Okay, this code I have given to you, and that CV code, in that my folder there is a subfolder called CV code. So this is the code. So I have told you in stereo image what we do. By a camera we take, by two cameras we take the same scene, we take the left image by the left camera, this is the left image, by the right camera, this is the right image. Okay, now what we do, we compute the disparity. Disparity is nothing but what I told you in the depth formula, that is f into ts divided by x minus x dash, right? The x minus x dash is also called as disparity. Okay, so disparity is x dash minus x, or x minus x dash, whatever. Okay, so that is the disparity. So by disparity, actually you can form a disparity map. Okay, these are the two image. So at each point you will have x and x dash. So do the x and x dash and you will get the disparity map. So this is known as the disparity map. And this is now, I think this is given in pixel here. So this is given in pixel here, so you can see. Okay, you can see the disparity map here. Okay, so you can see where the color is very dark, so at this positions you can see that disparity is 0. Okay, and where the color is going to yellow, so there disparity is there you have high value of disparity. Okay, similarly you can compute the depth map. Depth map is f into tx, or you can also call it as baseline, divided by, I have told you, disparity, that is x minus x dash. So here if you have f, if you have b, you already got the disparity, you can compute the depth. Okay, so let's every stereo images, you have same value of f as well as same value of b. Okay, whenever you are making a depth data set, so you have you will have the same value of f as well as same value of b. So here I have assumed a value of f as this, as taking the value of f in pixel and taking the value of b in points, okay, in meter rather, okay, in meter. So this I have assumed this. So if you assume this, you can get the depth map, okay. So this is the depth map. So you can see this is the depth map. And also epipolar lines are there. So epipolar lines I have also already defined you. So in rectified stereo images, corresponding points lie on the same scan line or the horizontal line. So that is the significance of the epipole, okay. Validates stereo rectification, helps visualize geometry of the correspondence. So this epipolar lines is not very clear, but epipolar lines means all the point will lie on the same x or the same horizontal line, okay. So that is the epipole. So these are the epipolar line in the two images, okay. So this is the thing, this is the code. So you can what you can do, you can open this code, and you can copy the code to your drive, and you can experiment with this code. With if you have two different stereo image, you can get all this depth and all your disparity map that you can do, okay. So by this I am ending the session for today, okay. I hope this session is helpful, and we will meet on the next Friday, okay, same time 6 to 8 p.m. Okay. Okay. So bye everyone.
Thank you, sir. Once again, happy Independence Day.
Yeah, yeah, very happy Independence Day to all of you.
You are not audible, sir.
Oh, sorry. So very happy Independence Day
Yeah.
to all of
Thank you,
you.
sir. Happy Independence Day.
Yeah, yeah, very happy Independence Day to all of you. Okay, and we will
Thank you
meet
so
on the.
much. Even on a holiday, also you came and took a
Yeah,
class for
you
us.
guys also came for my class, so it's equal from my direction also. Same thing. Okay.
Right, sir. Thank you so much.
Bye, sir.
Bye, sir.